All right, so this is about charging and discharging capacitors. And just a quick view here, if I find it, there we go. So here are capacitors. They're used in all kinds of electronic circuits. And let's see, when I click on videos here, we can see ceiling lights, dome lights. That's actually where I get this idea from. Flickering lights, light bulb, that kind of thing. So they are electronic circuits as well as household things that you might use, but you definitely have a lot of capacitors in your electronics like cell phones, computers, and so on. So this is going to be about charging and discharging capacitors. Let's see if I can find my camera here. I believe there it is. There we go. All right. So these two here are two capacitors. They're in series with each other. This one here is a resistor that allows me to charge these capacitors over a certain amount of time, because otherwise if I don't have it there, then they charge right away. So let's see, here's my timer, and we, that is you, are going to take data every 10 seconds. Don't take it at 0, by the way. This one here is the voltage across each of these, or both of these capacitors. There we go. Put in one lead and put in the other one. There we go. And you should be able to read that. So don't take the 0 measurement here. I'm going to turn the, okay, to pay attention to my phone here that may want to quit on me. So that its battery is actually going down here. That's kind of like a capacitor taking the charge in. And I'm going to turn the switch on. I'm going to start the timer, and then you would have to take measurements every 10 seconds, so 10, 20, all the way up to 100 seconds as these capacitors are charging. So here we go. And you take a measurement now. So you have like 10 seconds on the left here, and you have whatever that was, 1.01. I didn't pay too close to attention here. And then you take a measurement now, 1.52 in that neighborhood. And you don't have to be absolutely accurate. So 1.52, 1.51, something like that. Or here at 30 seconds, what was that, 1.96 perhaps? And those are the charging data for the capacitor. And here at 40 seconds, now. And as I said, all the way up to 100 seconds. So here's 50 seconds right there. And then there was 60 seconds right there. And 70 seconds is coming up right there. And 80 seconds right there. And 90 seconds there. And then the final one. And of course it says 1 minute, 30 seconds, but of course 90 seconds. So here's the 100 seconds right there. Okay. So actually, here's what I have to do. Just noticed that my cell phone is quite a bit out of battery itself. I should charge it myself. So here we go. I'm going to unhook the battery, and we're going to discharge now. I turned also the switch off until I'm ready. So now we're going to discharge, and let's see if my cell phone holds. Ready, set, go. So again, don't take a 0 measurement. The first one is going to come up here pretty soon. And take a measurement right now at 10 seconds. Right now. Right. Oh. Right. Now, sorry that I keep saying that right now over and over again. And right now. Now. That was 60 seconds here. So here's 70 seconds right now. Right now. Currently my cell phone holds up right now. That's 90 seconds. And we're getting to 100 seconds. Right now. All right, gonna stop this one here, this one, and I really have to charge my cell phone. And I'll be right back with showing you the analysis of these data. All right, so I reviewed my own data. I'm just going to give you the first three. You have to then first three data points each time. So I just typed in the table as usual on Desmos. Get that. So you would have to put the other data in. So for the X1 here, we have the 10 seconds, then 20, and so on. And here, this is really quick. Enter, 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 up to 100 seconds, unless I screw something up, make it more difficult. And here are the first three data that I have for charging the capacitor. So it wasn't 1.01, I believe it was closer to 0.92. And if you review the video, maybe you come up with a more accurate number. But as I said, you don't have to be totally accurate. I do take the 1.52 that I mentioned in the video, and I believe I also had mentioned the 1.96. And then I'm going to click on a little plus sign, and there are the three data points. And we'll start out with the typical linear relationship. So y1 is proportional to, there's the tilde again, m times x1 plus b, or typical line. And if you review the video, you will see that it actually moves up like this, and then it kind of peters out. So it's definitely not going to be a straight line. And I will show you in a moment actually what it is. In the meantime, though, I do have other data points here. And there we go. I finally got it there. So I have the discharging one. I might as well put it in the same table. So I'm just going to type in here in the column next to it, Y2. There you go. And for the Y2 here, I have the data points as I reviewed my own video, 1.92, 1.36, 0.98, and then you would have to figure out the others. Let's see. As usual, I'm going to do something like this. How do I do that? There we go. There we go, and make them bigger. There we go. And I'm going to change this one here to green. And then this one here, I'm going to make crosses. Them bigger. There we go. And I'm going to turn this one off here for the time being. And again, you also can see a curve that actually gets closer to the x-axis here. I'm going to put an equation for this one in here. So I have y2, that's what I put it in the table, is proportional to m times, well, the independent variable is the time, so that's under x1, and then plus b, and there we go. And again, it's a little bit off here, not too bad, but you will see that actually the remaining data, they just go over here, so completely away from the straight line. So I'm just going to give it away. This second one here is simply an exponential curve, and this is how we're going to type it. So I'm going to erase most of this one here. M times e to the power. E is a special number in mathematics, 2.71. We will encounter it at some point later when we talk about finances. It means later in the semester. So 2.71 is just as special as pi is, for the circle, but e is really important for other applications in mathematics. So I typed in e to the some power. I'm going to put a parentheses there, and here I'm going to put some kind of constant here, k, that I multiply with my second variable. So this one is going to, I'm sorry, my first variable, which is the independent one, the time, so x1. I'm going to close the parentheses, and you see that this curve here, which is an exponential curve, so it goes down and down, but then it kind of peters out towards the x-axis. You can see that this one here fits the data really nicely, which is not surprising because there are only 3 data points, but you will see actually that my data points, once you take the correct numbers there, are actually also pretty close to this one here. All right, I'm going to change the color on this one here. Let's see, which one? This one here, right? Yep, there we go. And then I'm going to put the labels on here. So this is t, time and seconds, or t and s, either way. Time and seconds on the x-axis, on the y-axis. It's already here, right there. On the y-axis, that was actually, I measured the voltage, and in fact, I measured the voltage in volts. There we go, and you can see it over here as well. All right, so I'm going to fix the other one here. So this was the discharging. That was actually a little bit easier. I'm going to fix the charging one here, and for the time being, I'm going to turn that one off. So this one here kind of looks a little bit similar to this one. I'm just going to copy this here. Now, you know what? Instead of copying, I'm just going to retype it. There we go. And give me just a moment. I have to figure it out myself. Okay, I'm going to start out with m times. Now I'm going to start at parentheses. And next, I'm going to have 1 minus e to the power. Oops, not a capital E, lowercase e. E to the power, and again, I'm going to do the same thing here. K, parentheses, k times x1, close that parentheses, go one over and close this big parentheses right there. And you can already see that this one here increases, but then it increases slower and slower, and eventually it's going to peter out. By the way, this here is going to be kind of like the total battery voltage that eventually will go onto the capacitor. You see the 2.841 there, so 2.8 volts. I had 2 AA batteries in there, so 3.0 volts, somewhere around there. So this one here, again, looks a little bit more complicated. And then, yeah, here's the other one. I'm going to turn this one on now. And, yeah, you're going to do your own Decimal sheet.